This is the working part of the Pi-Swerl unit. Basically, this is the flat end of the blade, annular because there's a hole in the middle, and of course flat because it's flat. And that when we talk about the blade spinning, this is what we're talking about. This thing spins at different speeds to simulate different wind speeds. So, for example, the test that you'll be doing, you'll be going up to a hybrid 4,000 tests, which means that it'll go faster and faster and faster until it finally gets to 4,000 RPM, which is of course very fast. This is a good time to mention that generally you'll have no business here. But if for whatever reason you're tempted to pick this up while it's still running or whatever, which you shouldn't do, then be very, very careful not to stick your fingers in there, because this part's moving fast. This is difficult to take off your fingers. So this is the blade, and these guys, there's 3, 4 of them. 1, 2, there's 3, 4 higher up in here. Those are called the optical gate sensors. And it's just like what it sounds like. It's an optical gate. There's light that shoots across from here to here, and there's a receiver over here. And basically we use these to count sand particles as they go by. So there you're going to find in the data files there's OGS 1, 2, 3, and 4. I'm not sure what the order is, but something like that. Finally, the clean air blower, which is mounted up here, sucks clean air from the atmosphere and blows it into the chamber vis-a-vis these ports. 1, 2, 3, 4. And that's basically what we use to dilute the chamber and exhaust the air out of it, force the air to come out.
Oh, mention the cleaning of the filter, because they'll be operating it long enough that they should do that.
Right. So speaking of the clean air blower, it's not super clean air in the sense that it's not like an ultra clean filter, but compared to the dust that's inside, it's very clean air. There's a little filter, and it's just actually a piece of sponge material. And this filter is just used to keep out big particles and butterflies or whatever. But every now and then this filter is going to get quite dusty. So periodically, maybe at the end of 2 days of use or something like that, this filter should be pulled out of this hole over here. You just basically squeeze it. You don't push it in, you just squeeze it, pull it out, and you kind of go like this. If you have
see dust coming out.
You see dust coming out, and if there's no dust coming out, it's probably clean enough. And if you have compressed air, then you can just use that as well.
Should we actually do that before, like, as part of our assembly steps?
It's better to do it at the end of the day as part of the cleaning.
Okay.
And George will go over how you should clean the whole instrument between sites. And then when you put this back in, again, you just kind of squeeze it against the side. Don't push it in, don't shove it in, because there are blades in here, and you don't want to kind of bind them up. So yeah, just kind of shove it in, and it just rests in nicely. It doesn't have to be jammed in there at all. And that's basically the Pi-Swerl, the working parts of it. On the outside, this is the dust track. We already talked about that. This is the cradle that holds the dust track. This is the clean air flow meter. So you'll notice that it's connected to the blower. The blower blows clean air past the clean air flow meter, and this basically helps us meter how much clean air is going in. So for the most of the tests, we set it at 100 liters per minute. So if the blower starts blowing harder than that, then this will say, hey, slow down, and slow the blower down. If it's less, then they'll say speed up, and we'll speed up the blower. Then this air gets routed into here, into the plenum, and from there it gets distributed to the 4 locations that we saw.
And mixed nicely inside the chamber, and then the dirty air comes out of this port.
The exhaust port. And this basically is just a piece of PVC that covers the actual port, which is just that. So you can just look from the top over there, you'll see the blade. Again, even though it might seem like it might be fun, try not to drop berries or acorns in there.
And yesterday you were talking about you could use that that exhaust port as a filter or a collector.
Yes, so you can use that. I mean, the air coming out here is dust-laden air, so you can use that if you have a certain application. You can try to collect filter sample there, so that you can characterize chemically the soil that you're emitting. Or if you collect a biological sample, if you wanted to hold, for example, a petri dish in some controlled way or subsample or whatever. I mean, it's just an exhaust port.
We'll figure something out.
Yeah. If you are sampling for air, then what you want to do is you want to make sure that this is nicely sealed at the ground. And this seal has been broken in, so it should be okay. But sometimes when this bottom seal is brand new, it's kind of puffy, so it's actually a bit more porous. So let me know if you're going to do that. We'll go through a slightly different protocol. To finish up over here, this is the junction box. Basically, all of these different pieces of equipment are connected. There are connections for them in here. And then this is a GPS. When you turn the unit on, it takes about 2 minutes, or sometimes a bit longer, sometimes a bit shorter.
If it's in a new location far away.
For the GPS to find a satellite lock, and once it does, then basically you've got access to GPS data. So when you hit run, it'll write the GPS coordinates to your data file. It's a nice feature, but don't rely on it because you don't have to lock at any given time. So it's nice if you're just kind of trying to figure out where you make the measurements. And also with the GPS, it's not like you can pinpoint that you can make the measurement over there. All you know is going to be roughly.
It's not bad though,
It's not
in
bad.
practice. I've kind of plotted in like going back of the DRI and doing fast and plotting them on Google
We already
Earth.
talked about the connector over here. So this is basically where the control cable comes. Okay, so let's go ahead and do
If
that.
I
I'll
do
do
a
it
line
now.
here and I start 1,
Actually,
2, 3 and I
here you go. You
space
do this
them
side.
meter and a half or more, you'll kind of know which one is which.
Oh, sorry.
When we do the accuracy a little bit, we collect the